We are here today to learn about scalene, isosceles, and equilateral, and how to prove it. But first you have to know the vocabulary. Scalene. A scalene triangle is a triangle with no congruent sides. So for example, if I had a triangle that was 4, 5, 6 in length, that would be scalene. An isosceles triangle is a triangle with at least 2 congruent sides. So 7 and 7 and 5, that would be isosceles. Now notice that it says at least. I'm going to come back to that in a second. An equilateral triangle has 3 congruent sides. So, for example, a triangle that had sides 5, 5, and 5 would be equilateral. Now, the question is, would this equilateral triangle also be isosceles? Is that one of those types of situations? All right, can it be both? And the answer is yes, because of the way it's defined. An isosceles triangle is a triangle with at least 2 congruent sides. That means if it has 3 congruent sides, it's still isosceles because it has at least 2 congruent sides. It still has the 2. So, in other words, an equilateral triangle is a special case of an isosceles triangle. So, every equilateral triangle is also isosceles, but not every isosceles triangle is equilateral, as you can see by this example. Anyway, just wanted to point that out. Please remember that length and distance are the same thing. The length of a segment is just the distance between the 2 endpoints. So anytime I'm asking you to find the length of something, or prove that 2 lengths are congruent, or prove that lengths are not congruent, if you have the coordinates, and this unit is about coordinate geometry, so you'll have a lot of coordinates to work with, you'll be using the distance formula to do length. So complete the table. Show whether each triangle is equilateral, isosceles, or scalene. So since knowing that something is equilateral or isosceles or scalene depends on knowing what the lengths are, or at least knowing if they're the same or different, then we're going to need these lengths. That's why we have to complete this table. So the idea is we've got these points like NBC, okay, and if we could find the length of the sides of the triangle, we'd be golden. I think it might help you guys if I draw sort of a diagram. So here's some random triangle. Maybe I should have made it more random, but anyway, we don't know if this is equilateral or isosceles or scalene yet. All we know is we've got ourselves, what do we call this one? Triangle NBC. So here's NBC. Okay, and N is 2, 5, 8, 7. Okay, so this is 2, 5, 8, 7, and C is 6, 1. Okay, so we would like to know the lengths of each one of these sides. So of course this side right here is side NB. So if I find the distance between N and B, that'll be this side. Okay, this side right here is BC, and this side right here is from N to C. So this is length NC. So you know, if I want to find the length of side NB, I could use the distance formula using these 2 points, okay, as my x, y, and my xy. Okay, so let's do that. So that's why here it says NB, so I'm about to use the distance formula using points N and B. So here we're supposed to do the calculation, so here's where we set it up. And remember, the distance formula is x minus x squared plus y minus y squared. It's really just the Pythagorean theorem, as I showed you the other day. So x minus x squared, so that's 2 minus 8 squared, and then y minus y, so that's 5 minus 7, so 5 minus 7 squared. And I recommend that you type the entire thing into your calculator all at once, just like this, and 2 radical 10 is what you get. So that's 2 radical 10. Whoops, why did I do that? Okay, and then of course, so we found one side of the triangle, NB here is 2 radical 10. Okay, so now we can find the other side, another side of the triangle, BC. So we'll do the distance formula again, using points B and C this time. So once again, we're doing the distance formula, but we'll find the distance between these 2 points. So distance formula, and so that's going to be, x minus x, so 8 minus 6 squared, y minus y, so 7 minus 1 squared. Put that whole thing in your calculator again, and what do you know? You get 2 radical 10 again. Okay, so it's definitely isosceles, but we want to be as specific as possible, so it remains to be seen if it's equilateral or not. If the other side is also 2 radical 10, then we will classify it as equilateral. But if the other side is something different, then we'll stick with isosceles. So, of course, this last distance that we need is the distance from N to C. So we will do the distance formula with points N and C. So we'll set up our distance formula. X minus x, I'm going to do 6 minus 2 this time. So x minus x squared plus y minus y. Okay, so that would be 1 minus 5 squared. So that's 4 radical 2. So we have 2 sides that are the same, but the third side is different. So we will classify this as isosceles. Alright, that is the classification. Classification means saying what type of thing something is. Alright, and that is how you do that. So let's just do this one more time. For some reason this says ABC, but then it's actually BMX. I'm going to do it without the picture this time, because it is the same concept. So I've got 3 sides of a triangle. If I've got points B, M, and X, one side of the triangle is going to be BM, another side is going to be MX, and the third side is going to be BX. So BM, MX, and BX. So if I find one side of the triangle, I will do the distance formula using using points B and M. So x minus x squared. So that would be like negative 5 minus 3 squared. Y minus y squared. So that would be like 1 minus 2 squared. So put that in your calculator. You get the square root of 65. Now, mx. So I'm dealing with these 2 points right here. So 3 comma 2 and 0 comma negative 5. So again, I'm going to do x minus x. So that's 3 minus 0 squared. Then I'm going to do y minus y. So that's going to be 2 plus 5 squared. Again, I'm adding 5 because that's what happens when you subtract a negative number. 2 minus negative 5. Minus negative is addition. So put that in your calculator. Bling! Radical 58. So far nothing. Alright, so if the third one turns out to be one of these, it'll be isosceles, but there's no way it's going to be equilateral. It might be scalene. Anyway, last pair. The last side would have to be bx. So I'm going to look at the last two, b and x, focus on those, as I do my x minus x and my y minus y. So negative 5 minus 0 is my x minus x squared, and now my y minus y. So 1 plus 5 squared. Put that in your calculator. Bling! So that's square root of 61. All three are different, so this classification will be scalene. Moving on. Okay, I think you get the idea at this point because the way I've done number 1 and 2. So, if you are following along, you should pause the video and do number 3 and 4 by yourself at this point. I've shown you how to do it, so don't just sit there and copy me or just watch me. This is not TV, this is math. So, pause the video and do number 3 and 4 on your own, and then turn it back on just to check your answers. So here are the results for number 3 and 4. As you can see, in problem number 3, triangle NWA has two sides that are congruent and one side that is not. So that's isosceles. Same thing happened for triangle PDQ. Two sides were the same, one side is not the same, so that is also isosceles. Alright, I'm just going to pause for a second to let you soak it in for like 10 seconds before I go on. Alright, I was mostly pausing in case you got something wrong. I was trying to give you a chance, assuming you worked it out on your own like you're supposed to, you could look and see what you did differently than I did in the setup of these equations, and so you could correct your mistake and understand and learn from your mistakes. Very important. Anyway, moving on to number 5. A triangular park is located at the corner of your neighborhood. Its coordinates are at -5, -4. So let's see, -5, -4. That would be right here. 3, 2. So that's right, 3 up 2. And -5, 2. So -5, 2. That's the coordinates of our park. Okay. So here's our triangle. Bling. Yeah, so you want to build a fence around the outside. So basically, this the triangle itself represents the fence. How many feet of fence would you buy? So if we're talking about feet of fence, obviously we're talking about the length of the fence, which comes in 3 pieces. So the length of the fence is going to equate to the perimeter of this triangle, the sum of the length of the 3 sides of the triangle. So we need 3 lengths. Now, if I wanted to do it the long way, I could use the distance formula like I did up here, and I could find all these distances. But because I have a vertical and a horizontal piece, it will be quicker just to count the squares. So this is 1, 2, 3, 4, 5, 6. So this side of the triangle is 6. That length of fence is 6 feet. This length of fence over here is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 feet of fence. All I need now is to find the length of the other side. Now, please understand that I could use my coordinates. All right, this was that point -5, -4, and this is the point 3, 2. So I could use my distance formula like I did up here with these problems to find the length. In fact, you know what, just to make a point, I think I will do that. So this third distance, I could go that the distance is going to be the square root of x minus x. I'm going to do 3 minus -5, which would be 3 plus 5 squared. Now y minus y, so that would be 2 minus -4. So I'm going to do 2 plus 4 squared. And I could put that in my calculator. That's going to give me 10. Alright, so one way to find this third length is to do the distance formula, and I get 10 that way. Let me change colors and show you another way that I could do it. I'll say, or I could have done the Pythagorean theorem to do it. I could say that the distance squared, c squared is equal to a squared plus b squared. So distance squared is equal to 6 squared plus 8 squared. And of course, I've tried to get you guys to understand that the distance formula is the Pythagorean theorem. So we're not really doing two different things. See your 3 plus 5 right there? That's the 8 that we have right here. See the 2 plus 4 right there? That's the 6 that we have right there. It's exactly the same thing. Just the distance formula does it all in one step instead of doing what I'm about to do now. Because normally what we would do is say d squared is equal to 36 plus 64. D squared is equal to 100. Then I would take the square root of both sides. And that's going to give me that d is 10. So look, basically the distance formula is sort of a shortcut. The formula does the Pythagorean theorem, but it has it all in one package. Okay, either way, we get that the third side is length 10. So that means the total fencing is going to be just, the 6 plus the 8 plus the 10. So that's 24 feet. Okay, so the total fencing is going to be 24 feet. Alrighty then. Now, if you wanted to plant grass on the inside of it, oh man, the inside. When we were doing the border, it was very clear to me that we were just doing the perimeter, just adding lengths. But when we are dealing with covering the inside of a shape, whether it's planting grass, laying carpet, laying tile, something like that where we're filling the inside, painting a surface, things like that on the inside, we are now talking about area, not perimeter. Area, not length. So, it will be helpful to be familiar with the area of a triangle, which is 1/2 the base times height. in case you don't know what I mean when I talk about base and height, let me give you a couple quick examples. Say if I have a triangle like this. Okay, here's a basic triangle. So usually what we will do is, the base of the triangle would be, for example, this would be one of the bases of the triangle. Okay, so that would be the base, however long that is. Now the height is the altitude. So if I start at this vertex, of course, in altitude is when you drop down a perpendicular like this. Okay, this has got to be perpendicular. So if this is the base, is this side of the triangle, this altitude right here would be the height. Okay, that's the base and that's the height. Now, if I have a right triangle, though, okay, things work slightly different, or just at least they appear different. So look, if I have a right triangle like this one, so let's say this is 90 degrees, then this is the base. But now the altitude is actually this side of the triangle. So in this case, this side of the triangle right here is actually the height. Okay, so this would be the base and this would be the height. Okay, so keep that in mind. What else can I say about this? There's no gravity on a piece of paper. Okay, what do I mean by that? I need you to understand that I could move these triangles around. I don't want you to think of the base and the height as I don't want you to think of the base as always being straight down. Say if I have this triangle, let me draw this triangle again. Say if I have this triangle, but say the triangle is turned like this. Okay, so here's my triangle. Any one of these three sides could be considered the base. Alright, so you just have to pick one. You just have to pick a base and height pair. But I could consider this the base over here. If this is the base, then this segment like this would be my height. Okay, the base and the height. Okay, so don't think the base always has to be at the bottom. It does not. Now with that in mind, let's look back at the triangle that we've got. Which one of these three numbers do you think represents the length of what we will use as the base? Well, I guess it's sort of a trick question because I just got through saying that we really could use any of these three sides as the base. So say if we decide to use 8 as the base. Okay, we could use 8 as the base if we want to. The most natural thing for me to do is to go ahead and consider this side 8 right here to be my base. Okay, if that's my base, then this will be my height. Only because you often see the base as being a horizontal length, and we often see the height as being vertical. So that's why it's natural to choose the 8 as the base and 6 as the height. But I want you to understand that we could have used the 6 as the base and the 8 as the height, and we still should get the same answer. So, but I'm going to go ahead and do it this way. So the area of a triangle, which is what we need to get to the inside for all this grass, is 1/2 the base times the height. So that means the area is going to be 1/2 times 8 times 6. Okay, Now I could work this out step by step by doing 8 times 6 is 48. So this is 1/2 of 48, and then half of 48 is 24. Now let's talk about units. When we're doing length, the units are just feet. But when we're doing area, the units are little squares. Okay? They're little 1 foot by 1 foot squares would be our units. So we write 24 square feet. And we write it this way by putting 24 and then feet squared, but we'd write it 24 square feet. That means 24 little 1 foot by 1 foot squares, 24 of these would fit inside of here. It would take 24 of these exactly to cover up this space. So that's how you do it. Any questions? Send me a comment. Send me a post if you have a question.